Hi guys, the next topic is analysis of feedback amplifier. In the previous lecture, we discussed about how to identify the type of feedback amplifiers. I told you there are two rules to identify type of feedback amplifier, and I also said that what is the shortcut method to identify type of feedback amplifier. And after identifying type of feedback amplifier, we have to analyze the amplifier circuit to get what is the voltage gain, input resistance, beta, feedback network value, and whatever the AC parameters that we need, we can find by using the certain rules. And this is what we are going to discuss now, analysis of feedback amplifiers. So there are 4 steps to analyze any feedback amplifier circuit. Step 1, first as usual, identify the types of sampling, and the second step, type of mixing, and third step, we need to identify input and output side circuit. To identify input circuit, if this is voltage sampling, make V0 equal to 0, which means you short the output terminal and take the remaining variables or resistance, capacitors are there in the circuit, you draw the input side. If this is current sampling, short the output terminal, open the output terminal making I equal to 0, then take the remaining variables which are present in the circuit. To get output side circuit, if this is series mixing, make I equal to 0, which means open circuit the input loop and write the remaining things at the output side. Similarly, if this is shunt mixing, make V equal to 0 by short circuiting the input side. By making short circuit at the input side, you take the remaining things and write it at the output circuit. Right? If we do these 2 steps, we will get the input side circuit and output side circuit for analyzing the feedback amplifiers. At last, we have to replace the original circuit into H parameter model, and by using this H parameter model, one can analyze the feedback amplifiers. Right? Let us take one small problem in this lecture, and we'll see how to analyze the feedback amplifier by using these 4 steps. We'll go step by step. Let us take a problem. So this is your RE, and we'll take output across this V0. This is your VS. Let us take this simple circuit and we'll investigate how to analyze the feedback amplifiers. So according to the actual rule, first thing we need to find out what type of sampling. Either by using the shortcut method or by using the actual rule, we can find this, because we have already discussed this circuit in the previous lecture itself. After shorting this terminal, there will be no feedback to the input side, because through the short circuit all the current goes to the ground, which means no feedback after shorting the output terminal. It is called the voltage sampling. And type of mixing, your source at the base terminal and emitter at the resistance at the emitter terminal, both are different terminal. It is called series mixing. So this feedback amplifier is voltage series feedback amplifier. After identifying this, what is the third step? We need to draw the input side and output side circuit. And according to the raw, the third step is, if this is voltage sampling, making V equal to 0, making V equal to 0 at the output side and write the remaining things at the input side. Are you clear? According to the step 3, to find input side and output side circuit. To get input side circuit, if this is voltage sampling, make this voltage short circuit and write the remaining things at the input side circuit. Similarly, if this is series mixing, make the input side loop open by making input current I equal to 0. Opening this, you write the remaining things at the input side, at the output side. You will get the input side circuit and output side circuit. Clear? So for our analysis, we'll keep one more resistance RC here. I'll repeat the step 3. If this is voltage sampling, to get input side circuit, make the output voltage short and write the remaining things in the circuit at the input side. To get the output side circuit, if this is series mixing, make the input current is 0 by opening the input loop and write the remaining things at the output side. That's all. I'll do this, just follow this. Since it is voltage sampling, you short this. After shorting this, there will be no RE. Write the remaining things at the input side because RE at the output side. So what will you get? We'll get source, RS, capacitor, and this. This is your input side circuit. To get output side circuit, if this is series mixing, make I equal to 0. Your input current is 0. It means this is your base current IB. Make I equal to 0 by opening this loop. By opening this loop, we can make the input side circuit like this. If I open this, we'll get only this. And when you do this, you have to replace your resistance as usual. RE resistance. Clear? Now, we have opened the input loop because this series mixing, and we'll write the remaining things at the output side as usual. So output side I have RC and R. This is your RC. And across this RE, we take output V0. So this is your input side circuit and this is your output side circuit. Since RE acts as a feedback, we can keep VF equal to this one. So this is your step 3 to identify input side circuit and the output side circuit. And after getting this, we have to draw the equivalent model of this by using H parameter model. And once we got H parameter model, we could find the AC parameters, whatever we want from the circuit. Now let us draw the H parameter model for this input and output side circuit. First of all, to draw this input side and output side circuit, we have to replace this transistor by its equivalent model, because transistor's equivalent model of H parameter model comes in the middle of the circuit. So first we will replace this one. So this is the H parameter model or equivalent model of your transistor. Clear? So after drawing this, we have to replace the remaining things. Your source, and at the output side RC, RE, on input side you have a RS. Since it is H parameter model, AC analysis, I removed the capacitor because capacitor's reactance value very low for the AC signal, or it acts as a short circuit, so I removed the capacitor CC over there. So this is the equivalent model of this circuit. This is equivalent model of this one. So to differentiate this, I will draw this one. This is the transistor equivalent model. The black dots shows that it is a transistor's equivalent model. Right, that's all. Now we have to find the AC parameter values, whatever we want from the circuit, but for the feedback amplifier circuit. Right. So first let us investigate what is beta band. Beta is a feedback network, so we have to consider the feedback side. Right. So what is here it is as a feedback, it is a voltage sampling. We give that into the input side as a feedback. So output is V0. which means sampling is V0. And this beta will decide the amount of feedback that should go to the input side. Are you clear? I have told everything in the very first lecture, introduction about the feedback amplifier, that beta decides the amount of feedback to the input side. This is your feedback and this is your output voltage. So because of this beta value, part of output signal will go to the input side as a feedback voltage. Since it is voltage sampling, we have to consider V0. Okay. And from this, beta is equal to Vf by V0, and both V0 and Vf drops are across the RE terminal, so V0 is equal to Vf, so both get cancelled. I'll get beta is equal to 1. Beta value is equal to 1. So after finding this, we have to find what is AV value, voltage gain without feedback or open loop gain. See, why do we need to find out beta and AV at first? The reason is, we have already discussed many times that in negative feedback amplifier, whatever the value reduces, it is only because of the factor 1 plus AV beta. If you recall your previous lecture, then you could come to know that by using this feedback 1 plus AV beta value only, your gain reduces and input and output resistance can be modified only by using this factor. So first of all, we need to find out what is beta and AV. Once we got these two, we could find the remaining things for the feedback amplifier, and that's the reason we try to find out beta and AVF at very first. So AV is voltage gain, so output voltage divided by input voltage. This is your gain, output by input voltage. Then what is the voltage? V0. V0 is across this RE, right? And current is HFE IB flowing through the circuit. Since it is a series circuit, current value is same. So this HFE IB makes one drop across here and another drop across here. But we take voltage across this RE resistance. So current HFE IB, current value into resistance RE, I into R will give you V0 output divided by Vs. This is your source voltage Vs, and since it is base, collector, emitter, we'll consider this current as IB current to the base terminal. This is also a series circuit, so current value is same. IB goes RS and RI. To get what is the total voltage Vs, I can consider the drop across this and drop across this. So IB into RS plus IB into HIE, that will give you the total voltage drop across this, because according to the KVL, this voltage drop is equal to this plus this. So IB into RS plus HIE, I into the total resistance at the input side. So IB get cancelled. We will get HFE RE divided by RS plus HI. This is your AV value. Clear? So once we got this, we can find the AVF, RI and RIF according to the feedback amplifier, especially for the voltage series feedback amplifier. I realize this. Since it is a video, you can copy this after passing your player. So we got these two. And input side resistance Ri is equal to total resistance Rs plus HIE. Then what is RIF? See, in the voltage series feedback amplifier, we analyzed, I think it is in the third lecture, we analyzed everything in the general amplifier, like voltage amplifier, current amplifier, trans conductance and the trans resistance amplifier. In that, you take voltage series equivalent amplifier. For voltage series feedback amplifier, what is the RIF value? Whether the RIF value increases or decreases by a factor 1 plus AV beta. You check the previous video, you will get clear idea about this. Because of this is voltage series feedback amplifier, voltage series feedback amplifier input resistance value is increasing by a factor 1 plus AV beta. You go check the previous lecture and see what is the RIF of the voltage series feedback amplifier. It is Ri into 1 plus AV beta, and we know what is Ri. So Ri into 1 plus, just now we have found AV value, it is HFE Re by Rs plus HE into beta value is 1, and do cross multiplication, Ra into Rs plus HFE Re divided by Rs plus HIE. Rs plus HIE is equal to Ri. So these two and this one get cancelled. You will get Rs plus HFE R. This is your RIF. So RIF equal to Rs plus HFE R. So here it will get Rs plus HI because of this cross multiplication. So here it is Rs plus HIE plus HFE R. This is your input resistance of feedback amplifier. Next we'll see what is the voltage gain of a feedback amplifier by using the same 1 plus AV beta. In normal negative feedback amplifiers, voltage gain reduces by a factor 1 plus AV beta. So if something reduces in the feedback amplifier, we already discussed that the reduction because of the 1 plus AV beta term divides the actual value. So for example, if it is AVF, then your original value AV reduced by a back factor 1 plus AV beta. Now we have to substitute AV, AVF and beta value to get the AVF value. So after substituting this AV, beta and AVF value, you will get HFE Re divided by Rs plus HIE plus HFE R. This is your final answer. You substitute AV and do cross multiplication, you will get the final answer like this. Similarly, you can find out R0F2. R0F is across this resistance Re. So Re by 1 plus AV beta. Substitute beta value, AV value, and you will get the R0F value. Then the R0F is equal to Rs plus HIE divided by HF. So like this you can identify the AC parameter by using the H parameter model. But actually what is the H parameter model is that it's a hybrid parameter model. Hybrid parameter model means H11, H12, H21, H22, we get many parameters, and different parameters has different unit, and some parameters may not have unit even. So that is why it is a mixing of unit and unitless values. We call this the hybrid parameters. And what is the main advantage of this hybrid parameter model is simply, see, look at the output of any H parameter model like this. You will get only resistance and HFE, HIE value. You will not get any current, voltage, input drop, output drop, anything you will not get at the output side. This is the main advantage of your H parameter model, because just by seeing the circuit, we can come to know Re, Rs value, or Re and Rs value are applied by ourselves. And this HFE, HIE value are constant for any transistor. So simply by substituting HFE, HIE and Re what we put in the circuit, we can identify the AVF. You no need to analyze what is the output drop, what is the input drop, and so on. Just by keeping the resistance and the H parameter values of a transistor, we can get the final answer directly from the circuit. No need to analyze KVL, KCL and other things. That is the biggest advantage of your H parameter model. So this is how we have to analyze the feedback amplifiers. First of all, we have to get what type of amplifier it is, and then draw the input side output side circuit. Finally replace the circuit by using the H parameter model and get beta and AV at first, and then we'll get 1 plus AV beta. This is for voltage series feedback amplifier. Like this, voltage shunt, current series, current shunt, you'll get GMF, RMF and AIF, because this is voltage series and the remaining three are equivalent to current amplifier, transconductance and trans resistance amplifier. So according to the configuration, you will get either AV or GM or RM or AI. So like this we can analyze the feedback amplifier circuits. Thank you.